All right. So this is going to be geared more towards the use of Git in software because that's where it's traditionally used the most. The concepts that we talk about, there's the very bare bones Git stuff, are going to be very applicable to what our hardware teams use. And by hardware teams, I mean Hannah's team primarily. The way that they use Git and GitHub will be very similar, just the practical application I'm going to be showing is going to be software. But again, concepts transfer. So just going to be going over a little bit about what is Git, how does it differ from GitHub, because they're not the same. And yeah, and then some basics about how to use Git, where to use Git, why to use Git, who uses Git. I think that covers them all. And hopefully by the end of it, you guys have a better understanding of this cool tool that we use and how to use it well. So without further ado, let's go ahead and I can't take credit for this amazing presentation. This was developed by Chase when we first did these presentations. But hopefully we will teach you how to get good here today. So just a little brief overview about what is Git. Git is source control, version control tool, software that was developed by the author of Linux. He actually developed it so that he could use it while developing Linux. And now everyone uses this because it's just such a great tool. So specifically the way we use it on our software teams, we use it to track versioning of our code repositories. On our hardware teams, we use it to track versioning of our schematics and KiCad repositories. We basically store each board as its own repository and track the changes that we make to each of those boards. So that way we can see the progress. So first thing here, some of you may have seen if you've used GitHub in the past. So big caveat up front, Git and GitHub are not the same thing. GitHub is a remote server hosting thing for Git, basically. Git is on its own, can be used locally on your machine without any connection to the internet after you download the actual package, of course, if it's not already installed. But past that, you can use it without access to the internet, without access to a browser, no GitHub involved at all. So you may have seen if you've used GitHub sort of as your Git client before, that GitHub has a desktop application that you can use. We don't like it. I personally just think that it doesn't teach you how it works. It abstracts away a lot of the cool features and a lot of the good understanding of how this software works. And all that stuff is really important to understand how to use it properly. It's sort of the babyfied version, and we don't like to treat you like babies. We like to treat you like adults because we're all adults and we can use Git properly. So before we get into it, just how to use Git, where to use Git, I guess this kind of answers both of those questions. Git is a command line tool at its core. So you need some sort of terminal to interface with the command line. And I think, I'm not sure how familiar all of you are with like Linux and command line stuff with Linux, but these are just some basic commands. If you are on Windows, you've likely been set up with WSL or Git Bash during onboarding. If you're on a Mac, more power to you. It's a lot of pain for the stuff we do. But Homebrew is a package manager for Mac OS. So if you are using Mac, look into Homebrew. You can install Git using Homebrew after you install Homebrew. And then from there, everything should be the same. But these commands will be there pretty much by default on macOS or WSL or Git Bash, any Bash client pretty much. So these, just to go over a few of them, and I'll show examples in an actual terminal sort of at the end, but this will just go over the basics here. LS listing folders. So if you think about your file explorer, how you sort of traditionally interact with your file system, on a Windows, it's File Explorer. On a Mac, it's Finder. Whenever you're in a directory, you're able to see all the folders and files in that directory. You're able to double click onto the directory to go into it, click the like up one level button to go up a level. So these are really sort of the things that are happening in the back when you do that, more or less. So when you type ls in the command line, it's going to list all the folders and all of the files in the current directory. So think of that as your window into your file explorer, where you're just able to see the things that exist at the current level. The cd command means change directory. So either that's going into a particular directory, like providing the name, or going up a level in the directory. You can provide relative or absolute paths. So we'll sort of go into that here in a bit. Nano is just a text editor. So you think of like TextEdit or Notepad. Those are separate applications that are used to edit raw text files. Nano is one that's built into your terminal that you can use to edit files there. Others include like Vim or Emacs that you may have heard of or seen before. All sort of the same concept, some a little bit more powerful than others, but Nano is a pretty basic one at its core. So always very nice to get started with that. And then the last few sort of commands here are useful for managing directories and creating or removing things. So if you want to make a directory, you think, you right click, you make a new folder in your Finder or File Explorer. This is the command that you would do in the command line. So you make directory, provide a name, and then that creates the directory. If you run an ls right after, you'd be able to see it. rm directory, right? rmdir, same thing, removes directory. You'll notice that a lot of, and I won't say all, because some of them are just whack, but a lot of these commands sort of mimic their functionality in the naming scheme. So mkdir, make directory, et cetera, et cetera. And then the last one is rm, just to remove something. So if you want to remove a file, you use rm. If you want to remove a directory, you use rmdir. So all these things, these are a very, very, very small subset of the useful commands, but they are some to get you started if you are not familiar with the Linux sort of command line. Okay, so now getting into Git. So Git is another, is a package that you install on your command line. Once you have Git on your command line, you have access to all of its functionality, and you're able to use it as such. So the sort of workflow that I'm going to go over here is the workflow that we would use at LHR when you're sort of just getting started and you want to contribute to one of our repositories. At the end, I'm going to go over sort of a live demo of how it would work from the ground up. So let's say you're starting something from scratch. So we'll get two perspectives here. So first perspective, again, is the perspective that we are dealing with at LHR. So you come on as a new member, as like most of you have. You're trying to contribute to your team's repository, your team's code base. So the very first thing you need to do is clone the repository. So remember how at the beginning I said Git and GitHub are not the same thing, right? They are not the same thing. GitHub is what we would call a remote repository. So that's what I'm going to refer to it as from now on, the remote repository. And the code that's on your computer locally is what we're going to appropriately call the local repository. So those are the words that I'm going to be saying from now on. That's what they mean. So what a clone does is it takes a URL, a link to your remote repository, and it clones it, and which is basically just a copy, or think of it sort of like a download, to your local machine, creating a local repository. So at the moment that you clone this repository, you have all of the code and all of the Git history that comes with it on your local machine. Now, when you make a change on your local machine, as you'll see here in a bit, that does not immediately reflect in the remote repository. Because remember, Git on its own is not reliant nor immediately connected to something like GitHub, a remote repository. You can use Git locally on its own, just by itself. And so once you clone it, most of your work will happen with just Git and whatever code development that you're doing, but you're just going to be using Git locally on your machine. Now, we use GitHub because obviously we collaborate and not all of us are working on one machine. So it pays to have some sort of remote server where we host all of the stuff that everyone can push and pull from to contribute and receive contributions from other people. So we'll go into how that links up on the pushing side later, but basically for a clone, once you have the repository cloned on your machine, at that point it's local. Any changes you make are local. Any changes that you remove, anything that you do basically, all local until you explicitly tell it to update the remote. And we'll go into how to do that in a bit. But that's what a clone does. So you have this repository. The example here in this image is the BPS repository, and it clones it into a folder local to your machine. So at that point, it's in your file system. You're able to interact with it as you would any other directory on your file system, and you're able to edit it the same as you would any other code base that you have interacted with before. So any text editor that you want to use, command line text editor like we talked about before, Nano, Vim, although the sort of editor of choice for most of us is Visual Studio Code, just because it's how we have most of our environments set up and it's easy to interact with things like WSL. So that's a clone. First step in our workflow of LHR new member, right? So second step in the flow, we make a change, right? As always, you're not here just to look at code, you're here to contribute to it. And I guess I should say, when I say look at code, edit code, for the hardware people watching this, this could mean, editing a board schematic, editing the layout, finalizing some parts, anything like that, right? So any changes that you need, whenever I mention the word code, also applicable to the hardware side of things. So when you make a change, right, we're able to see a few things about the changes that you make. And so these are some tools that we can use to both view and then finalize our changes, right? So the first thing that you might want to do when you make a bunch of changes, let's say you've been debugging an issue that your lead has told you to get on. You've made changes in 6 or 7 different files. You're not sure which ones actually work, and you can't really remember exactly the scope of everything that you've changed. So this tool here, the Git diff, is a great one to be using, because what this does is it goes through all of your files that you've asked Git to track, and it compares their current state to the state that they were in at the last commit, right? And once we get to this Git commit, I'll go more in depth on what a commit actually is. But for now, we'll just take it as is. So it compares the current status of your files, of your code, to what it was prior, before you made any changes. And so here you're able to easily see everything that you've changed, all the deletions you've made, all the additions you've made, compare line by line if you want to. And so it helps you see the scope of all the changes that you made, and most importantly, ensure that all the changes are ones that you want to finalize, right? So we're always wanting to make as few changes as possible to basically achieve the goal that we want to, right? It's almost never in our best interest to be making more changes than necessary. So the diff tool is very good to be able to see that. The next one is the Git status. So as you'll see, and again, I'll go through the live demo here at the end to go through everything. But the status shows the status of our staging area is what it's called. So there we're able to see what changes have we staged, which is sort of an intermediary stage between doing nothing and having finalized them, and what changes am I ready to finalize. So things like that, right? And they'll become more clear as we do the demo. But Git status just generally shows you the status of your Git repository, right? So of the repository locally, again, this is a local repository, nothing to do with the remote quite yet. It'll tell you the changes that you've made, the changes that you are ready to add or ready to commit, and all that good stuff. And the last thing here is Git commit. So here is sort of the bread and butter of what Git is. It's version control, like I said at the beginning, but how does it do that? It does it through this entity called a commit. So the easiest way to think of a commit is as a snapshot of your repository. So if you think of, you take a Word document, just going back outside of code, and you save it, right? You save this Word document. At that point, you have sort of finalized your changes, right? But the problem is, if you make more changes and then save it again, right? Most times you're not going to be able to go back to that initial change. Once you close it, maybe shut down your computer, all the cache is cleared. It's very difficult to then go back to your initial change, right? Unless there's some sort of version control within it. Another good example would be something like the feature that Google Docs has, right? I'm sure plenty of you have used that before. You're able to see the revision history in Google Docs or any of the Google Drive applications. And you can go back and see what the status of what your document, presentation, spreadsheet looked like at different points in time. It's a very similar concept, except the entity that we call them are commits, right? So a commit is a snapshot of your entire repository at some moment in time that you have deemed necessary to be committed, right? And so the history of your repository then is fully defined by this list of commits, this sort of linked list of commits, starting from the very initial commit that you have all the way to what we call the head, right? So again, I'm throwing a lot of terms at you just so that when you see them or hear them, maybe they sound familiar. But The head is what we'll refer to as the most recent commit, right? The one that if I were to add another commit, it would come right after that. That's the head commit, right? What we're at currently. So when we think of our history and our version control, when we want to see what versions we've had, what revisions we've had, they're all tracked through commits. So if you want to take a snapshot of your repository at any given time, you need to make a commit, because then it enables a lot of powerful things to happen, as we'll see here in a little bit. You're able to come back to that commit at any time. You're able to completely revert all changes that you've made since that commit and revert exactly to the status as it was then, which is very useful if you're debugging or you've introduced a bug in the program and you want to see where that was. Yeah, you're able to view it, modify there, change the repository, all that. So commits are very powerful, but they are sort of the bread and butter of what Git is at its core. So three sort of major things here, right? And so here, just going through it again, the diff showing here, the status after we've done here, right? So status will show you what's staged for commit. And then finally a commit here, this is what it will look like. Again, we'll go over a very concrete example at the end. And then we'll go over pushing in a bit. So I'm talking about a lot about what Git, now why Git, right? One of the questions I said I'd answer. So I'm going to start with the bottom two first. So line by line tracking, always wonderful, right? As much granularity as we can get is great. We want to be able to track exactly where we've been so that we can plan where we're going and see where we've come from. When we're developing large scale repositories like we do here at LHR, it gets very messy to try and manually track everything. So we don't manually track everything. We let a tool like Git track everything itself. And the second, that last one is something I've been sort of harping on a lot, is version control, right? So as we develop new features, as we fix new bugs, anything that we're doing, we're able to keep track of all the versions of our code that we have had, every single version. Now, it can get really messy, all these versions, and usually we're only really focused on a small subset of the versions at a given time. But again, it's always nice to have access. I remember there was a time we were debugging the battery protection system. This was about, what now? I guess before COVID hit, so around before spring break of 2020. We were trying to debug the BPS, it wasn't working. There was a certain feature of it not working. And we knew that exactly, or not exactly, but about 5 or 6 months prior to that, it had been working correctly. It had been tested. So what we were able to do is change the code, change the repository to exactly its state as it was 5 months ago, to exactly that commit, and then slowly narrow down which commit introduced the bug, right? There are tools that make that easier. I won't go into them right now. This is a Git basics tutorial, but there are Git tools that make that easier. But in an essence, we were able to, because we have these commits in this version control, isolate which commit the issue came out of. And at that point, we can see exactly which lines of code were introduced by that commit. Because at the end of the day, the bug is introduced by some set of lines of code, right? So by being able to view the commit exactly as it was, we're able to see the diff, right? Like we talked about, the Git diff between two commits, and see exactly what changes were introduced, and then make sure that we isolated the bug to the exact lines of code that introduced that bug. So very powerful tool for that reason, and amongst others. But that's just sort of a concrete example of how we've used it and utilized its power. And so that top one I said I would skip until last is having multiple people work on multiple things at once. So this is where GitHub or some remote repository plays a great role. Because we're working collaboratively and working with relatively large teams at times, it's very helpful to be able to efficiently and safely work on multiple features simultaneously as a team. So let's say you're on the controls system and Rowi's asked you to develop a feature for cruise control, right? The cruise control algorithm. At the same time, he's asked someone else on your team to fix a bug with the motor controller logic, right? So both of those are related, potentially dealing with some of the same code files, same C files. And we don't want to be working on the same computer. We don't want to be bottlenecked by each other. We should be able to work simultaneously without interfering with one another is the major thing. And so Git and GitHub together, what that allows us to do is that exact want is collaboratively work on them without interfering with one another. So we use what are called branches. And again, go over more that in detail in a bit. But a branch is sort of a copy, think of it as like that, a copy of your main code base that doesn't affect that main code base in any way. So I'm able to destroy the code base completely on my branch, rip it apart, make any changes I need to, debug, put it back together. And then at the end of my changes, I'm able to update the code base with what changes I've made. While simultaneously, the other member of my team has been doing the same thing, but to a different part of the code. And at the end of all of our struggles and debugging, we're able to bring everything together. So that way, all of our changes are safely and cleanly merged in. And that way, all the features that we had in mind were developed appropriately. So just sort of an abstract example there, but that's why we use it for more reasons. So we talked a lot about being able to go back and see these histories and all this, right? So what does that look like? What does it look like to see the history of a repository? And so here's a little image of what exactly that looks like. So Git commits are identified by what are called their commit hashes. So the hashes are strings, alphanumeric strings that are unique. So each alphanumeric string is, like I said, unique to that commit. If you want to look at a certain commit, all you need to do is provide its hash, and you're able to see exactly that string, right? So you can see, or exactly that commit, right? So the command that we use is git log. So log is the history log of our repository. And if you so please, you could look through every single commit that went into any one of our repositories. The example here, I believe, is the BPS repository. Yeah, CLI temperature. So at this point, if you want to look through every commit in the BPS repository, it will take you quite a long time. There are lots of commits, but if you're interested, you can do it. And that's the point, right? You always can look at any commit that was made in this repository, even when there are probably over 1,000 at this point. So you can see here's an example, right, of on this screenshot alone, there are 4 separate people's work being shown within the span of a few months, right? So from May to June, Sijin, myself, Clark, and Chase all worked on this repository on different features simultaneously, and we're able to introduce our own features individually while not negatively impacting each other. So very concrete example there. All right, another important thing that we are able to do, something I mentioned previously in this presentation, was because we have this history of these commits, I'm able to isolate individual commits, and that means that I can actually undo specific changes that I've made, as long as they are all in one commit. So that's another very powerful thing, right? And we do that by looking at the log. Remember, the commits are uniquely identified by their hashes. So nothing specific here, but I'll do an example of all this. Like if you make a mistake, which sorry, that there is. So if you make a mistake, it's going to happen. I've made plenty of mistakes in the BPS repository. Like I said, you can look back at the lots of commits. I beg that you don't, because you'll see my struggles from when I first joined the team. But if we go back here and we look at the history, right, we're able to see that there's one commit from Chase, one from me, one from Clark, another one from me under my GitHub username. Okay, that's weird. And one from Sijin. So 5 commits there that we're looking at. So if you look here, it's a little small, but I'll read it out. The beginning digits are 9DE3. And if we go back here, that commit is, unfortunately, my commit right here, right? So this 9DE3 commit, where my message says that it fixed the CLI temperature commands appropriately. But let's say that it didn't actually fix what I thought it fixed, right? Yeah, so let's say it didn't fix what I thought it fixed, right? So all those changes, I want to undo them. So when we say undo, we're not removing them from the history, right? Because the history is important to preserve. We want to see the changes that we made. We want to keep track of everything. But we can undo the changes that were made by that commit. And what I mean by that is you introduce what's called a revert commit, right? So this last commit here, you see it's new. It wasn't on the top here before, right? This commit is new. And you can see the message says it reverts that, right? This commit here and points to its actual hash. So you're able to uniquely identify it. And so all you need to do is git revert, provide the hash right there, and it will introduce a revert commit that takes all the changes that were made in the specified commit and undoes them, right? So anything that was introduced gets removed, anything that was removed comes back, right? Very nice to be able to do. Very messy to be able to do the further back you go. Again, this is a basics tutorial, so we're not going to go too far in depth, but be careful with using this if you're trying to revert something that's very far back, because it could have been a dependency for other commits in the future, right? So just something to be aware of, but always an option to undo the changes that you made, which is very powerful. So we talked about branching, right? Now, just to give a little refresher, because it was a little earlier in this, branching is used to isolate any changes that you make from what we call the main branch. So when we say main, that means our production code, the code that we're putting on these boards, the final version of the code, right? With everything that we need, no bugs, ideally. Put an asterisk there. So these are the commands that we use to deal with branches. So the bottom one there, git branch, allows you to, as it says, do various things to branches, the most common one being create one. So if after the git branch command you provide a name, so some string, it will create a branch with that name that branches off of whatever current commit that you're on, right? Whatever current branch you're on, it'll branch off of that relative to it. So if you're on main, it'll branch off of main. If you're on another feature branch, it'll branch off of that feature branch. So as you're getting ready to branch, that's one thing that I will say. Whenever you're branching, be aware of where you are branching from, because that will impact all of the commits that you have access to. So for a concrete example, let's say main consists, of 3 commits. Someone else branches off and creates an additional commit, a new feature. Let's say that you have been tasked with implementing something that relies on that feature. We'll call it feature A. Your feature B relies on feature A. It would be very difficult to develop feature B without feature A's code, right? So one thing that you could potentially do is wait for feature A's code to be merged into main, at which point there would be 4 commits in main and you could branch off of main. But if you are in a rush, if there's a time crunch, if you trust the person's code that has been written, but it just hasn't yet been merged in, you can then branch off of their branch, at which point you'll have access to all 4 commits already. So just some things to keep in mind as you're deciding where to branch from, how to branch. These are the things to think about. So once you create said branch, you would use that top command there, git checkout, and the branch name to actually check out that branch, right? So checkout means that I am changing my branch to the specified branch name that I provide. And at that point, your code, your repository will look as though it is just in that branch, whether that means it's different from the main or not. At the point where you branch, it'll be the exact same, but once you make changes, it will be different. If you're checking out someone else's branch that you are trying to maybe work on, it will make sure that all of your code changes to whatever the status of that branch is at the time, the last known commit. And then you can combine the two with that middle command there. So if you provide a git checkout and then a -b flag, that just means create the branch and also check it out at the same time. So just a little nicety there, but not necessary. Okay, so here is sort of, as we've been walking through the flow, let me go back and sort of explain in the context of this flow, right? So we started here with cloning. You take the repository of your team, you make changes, you add them, you commit them, right? This is why you can see the history. Maybe you made a mistake, you revert a commit, you check out a new branch, do all that. At the end of all of the changes that you've made, it's very important that you are not the only person to have seen this code before it goes into our main branch. It's not that we don't trust you, but it's mainly just that we don't trust you. And we don't trust anyone individually, right? I don't trust myself individually. The power of working on a team comes from the team. And it's very dangerous as an individual to just assume that because you think what you wrote works, that it will actually work. Reviews are very, very important. They're vital to healthy code development. Other people taking a look at anything that you work on, whether this is software, hardware, not even computer related, is always important because you don't necessarily see all the changes or all the issues that someone else will see. So here at LHR, we make it a very big point to make sure that no one is allowed to merge their changes or push their changes to our main branch until someone or multiple someones on your team have reviewed and approved those changes. Now, this can be for purposes of making sure that there are no bugs introduced in your code, making sure that the feature that you developed actually matches up with the expectations that were given, or just for code style, right? Because that's also very important to be able to have readable code. Consistent code style is also very important. So any one of those things could be reasons that someone says, hey, we need some changes made to your pull request is what they're called. So it's a request that you make to pull your code into the main branch. And so it's very controlled, it's very safe. It ensures that our main branch is protected from any dangerous code that might have been accidentally introduced by someone who maybe didn't look over their code all that well, or just couldn't see a potential breaking issue. So again, it's not that we don't trust you, it's that we don't trust any of us, right, individually. We trust ourselves as a team, as a unit. So we take advantage of that team and that teamwork. So pull requests are very important, very powerful things. Your team lead will have most likely a set of checkpoints or things to do before you actually submit a pull request. On our software teams, it could be something as simple as making sure the code compiles. On the hardware teams, we have a QUAC document, if Hannah has not mentioned it yet, a checklist of things to make sure that you've done before you can submit a design or a design change to a board. And that will be a part of your pull request or your review to make sure that all the code that you're writing, all of the hardware that you're designing is up to spec and up to par with our standards. All right, so before I go into live demo, does anyone have questions over what I've said so far? Because I've said a lot and I've talked and I've said a lot of words. So anything thus far? Perfect. All right. If you have any questions, just ask. Again, just sort of an informal thing, but I'm going to go for a live demo now. So let's see what this looks like here. Let me pull this up, and do a new screen share right here. Okay. So, like I said at the very beginning, the workflow that we sort of showed up until this point was that of someone cloning a new repository or cloning an already existing repository, working on said repository, making changes, creating pull requests. So we're going to go through all of that here, except we're going to go from scratch, which is the unique thing. So what do I do if I have literally an empty folder and I'd like to make a Git repository out of it, contribute to that Git repository, establish a history, link it to a GitHub repository, and open a pull request on a new branch? That's what we're going to talk about here, now that we have sort of those basic tools out of the way. So the very first thing you need to do, and this is our handy dandy command line right here, right? You have an empty folder, as you can see on the left here. There's absolutely nothing that exists. The git command is what we're going to be using for anything Git related, right? Git is our command. It takes in arguments to say what we're doing. In Linux, just in case you're wondering, everything is space separated. So no hyphen. This is one argument. These are two. So what we say in order to create our Git repository locally is we use this command called git init. I'm sure you can guess. Init is short for initialize. So it's as easy as that. Initialize empty Git repository in this folder, this directory. If you use our ls, you'll see that nothing's there. Ooh, scary, nothing happened. Well, if you use the -a flag for all, you can see that actually something did happen, right? We have this dot folder here, this .git. You notice that on like Windows and File Explorer, dot folders are hidden by default because they're sort of used by lower-level programs that most users of Windows and stuff don't need to see. We do need to see them, or it's nice to see them for us. So we can see that this created a .git folder. This is where everything that your Git repository knows about your code is stored. It's where all the history is stored, all the commits, all of your snapshots of your code, everything is stored there. So that's a very powerful folder. see it, don't freak out, definitely don't delete it. That's that. All right, so now that we have access to that, we can see that we can use the git commands. If you ever get confused, just type git. Right? It'll give you some good helpful tips here. But we're going to create a very small C program. I know Chase did a C basics thing block talk last week, so I mean this is going to be using only very basics. It's not going to be a very advanced C program, but we'll be able to see some features that we're developing like that, right? So as you can see here, if I want to see what branch I'm on, I can always just type git branch. I'm not on any branches, I guess. Let's see, you want a branch yet to be born? Yeah. So because I have not made any commits yet, there's no branch, right? So branches, I guess I should say that. A branch, really what a branch is it's a pointer to a specific commit, right? So as I was saying before, commits are the bread and butter, the bones behind Git. So the branches are really just a fancy way of looking at commits. So you have these commits, a branch is just a pointer to a specific commit hash, right? So there's nothing to do yet with Git because I haven't created any code. Let's say I do create some code, right? Let's make a main.c right here. Move you all over there, right? And let's say that my main.c is going to do something absolutely spectacular, right? Something that the world has never seen before. It's going to print a message to the console and wait for it. And say hello LHR because I'm special like that. And I don't do hello world programs. I do hello LHR programs because I'm cool. So this is what our program's going to do, right? I've made my changes. I've implemented my feature. This is my first change that I've made. The very basic bare bones of this repository. This is the beginning of what it's going to be. This is the exact code that I'm going to be able to see when I come back in 10 years and want to look at this repository's beginning. So again, we can look at the Git status, right? We talked about status. We can see there's no commits yet, but there are untracked files. Okay, so let's talk about this jargon here. An untracked file is one that Git has never seen before. A file that has either been created since the last commit or was ignored since forever and is now no longer ignored. In this case, it's a new file that Git has never seen before. So what we do is we add it to our staging area, right? So you see here an untracked file in red. This means that it's not ready to be committed yet, right? Nothing added to commit, but untracked files present. Use git add to track. It's very nice about telling you what to do. So we use the git add command and we tell it the file that we want to add, right? So main.c here is the file that I want to add. I look at git status, you can see these are my changes to be committed, right? So anytime you see green, that means that they are what are called staged, right? So staged to be committed. So anytime that you make changes, you stage them and you stage only the ones that you want to commit, which means that you can take a subset of the changes that you've made and stage only those and then commit them and then maybe commit the others in a later change, depends on how you're using it. But in this case, we're staging everything that we've changed. So here we have main.c. And now that we have it added to our staging area, we can commit it, right? I'm going to use the -m flag, which basically means I'm going to provide you a message in quotes here. Every commit needs a message to describe what it does. What we like to do is the commit message should tell us what the new code that you're doing does or why it was implemented, right? So I'm going to say explicitly what this does, right? It adds initial file to print message to console, right? That's what the commit does. So when I look back on this in 10 years and I'm wondering, why the hell did we add this commit? I know why, because it was a very explicit, very clear message. So I commit, right? Adds initial file to print message to console. Beautiful. Now you can see, we can always look at our history, right? Here's our history, very brief, a single commit. And you can see here that we have this master, right? That's the name of our branch, is our master branch. And again, like I said, it's a pointer to this commit, right? Nothing special. It's just a pointer to this commit. It just says, hey, if you want to go to master, you're going to look at this commit. Head again is our most recent commit that we're looking at. And so I can see who made it, what their email is in case you want to email them and tell them that they made a stupid change. date and time that it was made, so we can track changes that way. And last but certainly not least, the message associated with it. So now that I have this, I can go back to my status, and I can see that there's nothing to commit, right? No changes have been made since I last committed. But let's say that, I want to make another change. I don't like compiling my files, manually using GCC from the command line. So I'm going to make what's called a makefile. I'm not sure if Chase went over this, but not super important for purposes of this demonstration. Basically just a way to sort of script compilation. In this case, it's not super useful, but I'm just going to create a pattern here for it to follow, so that way when I type make, it'll automatically compile my code. Right? And then I can run main, and you can see that it does what it's supposed to do, right? So now I've made new changes. I've added a makefile, and I need to make sure this is part of the repository, because makefiles are important. They tell us how we compile properly. So check my status. I have two untracked files here. I have a makefile and I have main. Now I don't really want to track main because that's an executable. Executable shouldn't be tracked, right? They're not human readable. They're not really useful in being tracked. They just take up space, and there's no point, right? So it would be a very big pain for me to individually at all times never include main in whatever I'm doing. So we're going to add what's called a git ignore file here, right? .git ignore is the pattern that's recognized. And I'm going to tell it to ignore main. You just have a line by line separated list of all the files or file patterns that you want to ignore. And then if I look at my status, you can see, hey, I have git ignore, I have makefile, but main is nowhere to be found, even though the file still exists. So git is no longer paying attention to it. It is ignoring it appropriately. So let's say that I want to commit my git ignore, right? I could commit all of this at once, but the two changes that I've made are sort of unrelated. So it might not be the best idea for history's sake to sort of join them together. So what I'm going to do is I'm going to make individual commits. And so since I have two files that I'm using, I can specifically say I want to add git ignore. Right? You can see in my staging area, git ignore is there, changes to be committed. Makefile is still on my untracked files. So here's where we see the beauty, right, of the staging area. When I commit and I say this adds a git ignore, and I go back to status, you can see that commit took into account this change, but left the makefile as is. The changes are still there, but they are not part of the history yet. And so if I go into my log, I can see my two commits that I've made so far. Beautiful, right? Now, if I look at my status again, I have makefile. Hey, I want to add this makefile. And this says adds makefile to build easily. And now if I look at my log, I have these three commits that are very clearly separated by their purpose, right? The very first one's purpose was to add the source code to print to the console. Second one's purpose was to add the git ignore. Third one's purpose was to add a makefile, right? Now, let's say that I'm going about my day, I'm making some changes. I was told to implement a feature, right? I do all this. I accidentally swap the letters. Ooh, scary, right? I've made a mistake, but I haven't noticed it yet because it compiles, right? I'm like, oh, great, it compiles. That must mean it's working, right? So then I add this. I'm just going quickly. I'm used to using Git now. So I'm just like, hey, this makes some nice changes to the log message. And then I look at it and I'm like, great, cool. And then I look back at my code. Oh, shoot, that's wrong, right? That's really bad. That's a breaking change. That's ruining my code. Now I could, in this example, obviously, identify very easily what the thing is to change, just change it back. Or you could go back to a point in time where it was perfectly fine, right? So you remember that revert command that we talked about earlier? Very helpful here. So here I have this commit that I'm looking at, right? The one that I said make some nice changes to the log message. I'm just going to go ahead and copy that message or that commit hash. I'm going to revert it. Cool. So I'm going to say I want to revert this commit because it's bad. It's a bad commit. I hate it, hate everything about it, hate everything it stands for. So I'm gonna make sure I get rid of it right now. So I revert it, right? It's gonna ask me, hey, is this message cool? Because remember, this is a commit as well. Revert commits are commits. They're just doing something special, which means that they need a message. And the message here is auto-generated, is very useful already. So we're fine with that, right? It just reverts that commit and it tells us exactly which commit it reverts. So we're done with that. Now if we go in our log, we can see, hey, we reverted it. And we look here, we can see, oh, cool. Our code's back to the way it was before, right? Sounds peachy keen. Now, sort of last local thing that we're going to talk about is branching. Very powerful. So let's say that your team lead has asked you to branch off, right? Or create a new feature. So when they say like, let's develop a new feature, I want you to do a bug fix, anything that you're doing, you're never going to be dealing directly with master or main or whatever the primary branch is called. Excuse me. What you will be dealing with are your feature or bug fix branches. So let's say the feature that they want us to develop is to, I don't know, abstract this away, right? Main doesn't need to do the printing itself. We should separate this logic into its own method that does that, right? Sounds great. So what we're going to do here is we're going to get branch and I'm going to provide a name. I'm going to say this is a method separation. It's a branch name that appropriately describes the purpose of the branch. Very important. You'll notice that whenever I'm talking about naming conventions or message conventions, we always want it to appropriately describe the purpose. That way, anyone who's not directly working on it can be aware of what's happening there. So I get branch. Now, if I just type get branch, I can see all the branches that I have locally. I have master, which I'm on currently, and I have method separation, which I am not on currently. The command that we use to go check out that branch is appropriately called git checkout. So I type in the name, git checkout method separation, and now if I do git branch again, you can see, hey, now I'm on this branch. You will notice the commit history is identical because we have not made any new commits. All that happens is that now both master and method separation point to the same commit, right? Remember, branch names, branches are just pointers to a commit hash. So we now have both of them pointing to the same commit. But that's not really the point, right? The point is that we want this to be different because we're developing a feature. Cool. So I'm going to make a new method. I'm just going to call it print message. Not going to take any parameters. It's not going to return anything, but it's going to print LHR from the method, because why not? And I'm going to call this method from my main. Cool. So not dealing with Git yet. I'm just going to make this. It's implicit declaration. So I'm going to shove this up here just for ease of development. I'm going to make it. It's going to compile. I'm going to run main, and it's going to run exactly as expected, right? So I've run, this is me running all my test cases locally, ensuring that it's working correctly. So at this point, I can look at my status. I'm on method separation branch. Always good to check that you're on the correct branch. And I've modified this. So notice now that this is not untracked. Main is now tracked. It means it has a history in this Git repository. So this Git repository knows things about main, knows its history, knows its deep dark past. So at this point, it's just modified. So when we add it, we just add the changes, right? We're not adding everything, just the things that we've changed. So I'm going to add, and here, the little shortcut, the period. When I do that in Linux, period means current working directory, which is, in this case, this. So when I tell Git to add everything in the current working directory, it will look everywhere in the current level and below to see for any changes and add all of them to the staging area. So a good shorthand, but not always the thing that you want to use. Just it's good to know what it actually is doing. So to do that, I look at my status. It's modified and it's in green, saying that its changes to be committed again. So I make a commit. Remember, bread and butter of Git. So I say this abstracts print to its own method, right? Now I look at my log. You can see they've diverged, right? So this original commit, which is where we came from, which is where we branched off from, is where master is still pointing. We haven't changed master. That's still there. But method separation, on the other hand, method separation has its own new commit that master doesn't have, and that's what it's pointing to, right? So let's say I just want to go back to master, which I can do. You can see my code's updated. This is what the code looked like at master, right? Our changes are not gone, obviously, right? We just go back, if I can spell, go back to our fancy little branch here, and we can see that the changes are back. So whichever branch I'm on, my code reflects that. Cool. So what we do here is we want to push all of this to a remote repository and then open a pull request, right? So we're going to act as though we need someone to review our code first, right? So I'm going to check out master, right? So again, this was created fully locally. This is not linked to a remote repository yet. It's fully local. So what we're going to do, and I'm just going to share my entire screen. So we do this. I think I'm sharing my entire screen. Yeah. Okay. So on GitHub here, I've gone ahead and created a fresh remote repository. I'm going to add this as the remote. So this is the command. You don't need to memorize this. This will, like, you'll always have access to what this is. This isn't one that you use quite frequently. But I'm going to add this as my remote repository. And then I'm going to push -u means I'm setting the branch name that I provide for the origin being the remote. So here the nomenclature is I add a remote, I'm going to call it origin, and this is the link. Now I'm going to push to origin's branch called, I'm just going to call it master to keep it the same as we have locally, but the tradition, what we're trying to switch to is using main. So I have all this. And so I push all of this, do that. Yeah, write my key password. And now if I look remote, I have all the changes here just on master, right? So this is now our remote repository. Other people can see it. Final steps that we're going to go through are these. I want to go to a method separation branch, right? You notice that I cannot find that branch here on GitHub because I haven't pushed it yet to the remote, but I'm going to do that using the same sort of command, right? So I'm going to push that. And you can see, oh, whoops, did not need to do that. Automatically GitHub has recognized, hey, you recently pushed changes. Do you want to open a pull request? Yeah, I definitely do. Right? So this is what it does. You could provide a nice description, the checklist, etc. Anything here. You can add reviewers, which when we're actually on our repositories, you will have reviewers to add. And you press create pull request. At this point, we can very easily see the commits. We can see the files changed and the diff. So the view, like the git diff that we saw at the beginning, and all of that amazing stuff, right? And so at this point, what would happen is your team lead or someone else on your team would be reviewing your code. They would take a look at it. They would leave you comments. They would approve or ask for changes and such. And that is pretty much it. So Git, again, is local, used locally on your machine. We link it to GitHub, our remote repositories, to be able to collaborate with other people on your team, open things like pull requests, protect our branches appropriately, and keep track of our changes on a remote server. But that was Git Good plus some live demo. If you have questions, feel free just to ask. Obviously, you'll get comfortable with it as you use it more, but I hope this was a good introduction to it. I hope you learned a little bit today, and hopefully this will come in handy as you start working on the actual car and all the software and hardware that we're dealing with there. So that's that. Thank you all for coming out tonight. Have fun with the rest of your Thursday nights, and I will see most of you probably on Saturday. Yeah, thanks guys.